Hi everyone. The purpose of this video is to help clarify some of the things that you encountered in the activity today in class. The first problem set gave you two functions, f of x equals x squared and g of x equals 2x minus 5, and asked you to match each of the functions in group 1 with the correct expressions in group 2. The first item asked you to find f plus g of x. We should start by rewriting it in its easier to read notation. F of x plus g of x. We're going to take the expressions for f and g and we're going to substitute them. So substitute x squared for f of x, substitute 2x minus 5 for g of x. And then finally we collect the like terms. Since we have an x squared term, an x term, and a constant term, there actually are not any like terms to collect. And so this is how we leave our final expression for f plus g of x. Item number 2 asked us to do f minus g of x. Once again, we'll rewrite in simpler notation as f of x minus g of x. And then we'll make the appropriate substitutions. One of the really important things that people forget is that I need to see g of x, that 2x minus 5, that expression needs to be considered as one thing altogether. And to show that, I need to use parentheses around the 2x minus 5. This means not only am I going to subtract the 2x, but I'm also going to subtract the negative 5, which is going to give me a positive 5. Some people also like to think of this as distributing the negative, or as there's a negative 1 in front of the parentheses and you use the distributive property to multiply both terms by negative 1. Either way, there are no more like terms to collect, and so the expression for f minus g of x is x squared minus 2x plus 5. The third item asks us for fg of x, which I will rewrite as f of x times g of x. Once again, I'm going to make the substitutions, and it's really important that when I multiply, I remember I'm multiplying the functions as a whole, so I need to see 2x minus 5 all as one thing together. Therefore, again, it's going to be really important to use parentheses so that I don't forget the distributive property. So x squared times 2x is 2x to the third, and x squared times negative 5 is minus 5x squared. And since one of the terms is at x to the third and the other one is an x squared, there are no like terms that I can collect. And so my expression for fg of x is 2x to the third minus 5x squared. Finally, we're going to do f divided by g of x. As I did before, I'm going to rewrite and make the appropriate substitutions. And once I get to this point, I'm actually completely done. There is nothing else I can simplify any further. I know it gets really, really tempting, but you're done. There's nothing else you're able to reduce because of the fact that I put over here on the screen. If we were able to do that, then we could say 1/3 plus a half is a fifth, and we all know that that's total complete crazy talk because the fractions have different denominators. So again, avoid the temptation. Don't simplify things any further if it doesn't work. Okay, so there's the first four, which was kind of the main point of what we did in class today. And you're probably still like, so what the heck is this fog and goth stuff? Like, I know sometimes there's fog over Lake Michigan, and maybe sometimes people like to go out and play golf on a nice day. But where in the heck is that 4x squared coming from in the thing that looks like fog? And in this thing that looks like goth, where's this 2x squared coming from? We'll get into this more thoroughly, actually, in class. But in case you're curious, the next slide will kind of show where the expressions for number 5 and number 6 actually come from. So if you look at the colors, hopefully that maybe gives you a big hint at what's going on with this fog and goth business here. But if you don't see it right away, don't worry, we're going to do some more activities tomorrow to help us get more of a handle on what this is and how it works. So the next set of problems here, given the two functions and being asked to add, subtract, and multiply them, will just help us to review some important concepts from Algebra 1 that hopefully you remember. So for f plus g of x, I'm going to rewrite it as f of x plus g of x. I'm going to make my substitutions. And then in this problem, I actually do have some like terms that I can collect, which is the two x terms, and then also the two constant terms. So my final expression for f plus g of x is negative 7x plus 11. Secondly, for f minus g of x, we'll rewrite it as f of x minus g of x. Then we'll make the substitutions. Again, notice the use of parentheses for the g of x function in blue. Because I'm subtracting the function in its entirety, when I subtract negative 5x, it becomes a positive 5x. And when I subtract positive 2, it becomes a minus 2. And so when I collect my like terms, I get 3x plus 7 as my expression for f minus g of x. Finally, we'll do the multiplication, f times g of x, which we'll rewrite as f of x times g of x. Again, it's important to use parentheses for the multiplication, so I show that I'm multiplying the entire expression for the function together and treating it as all one thing. And then I need to remember to double distribute in this case. So first I distribute the 9 times negative 5x, and 9 times positive 2. And then I distribute the negative 2x, negative 2x times negative 5x, and then negative 2x times positive 2. And so the expression for f g of x is 10x squared minus 49x plus 18. The final problem set asks for f plus g, f minus g, and f times g of x for f of x equals cube root of 6 minus 3x and g of x equals 2x cubed plus 1. Like we did before, we'll rewrite it, we'll make the substitutions, and really important thing, that cube root symbol around the 6 minus 3x, That's like a big parentheses. You'll also learn later in the year that it's kind of like a exponent. Therefore, we are done. Another really important temptation to avoid. Yeah, this looks kind of familiar with the division. Again, remember that big radical with the cube root, that's like a big parentheses. And if you were to try to break it apart or try to simplify the things inside, you would be breaking order of operations because you'd be doing an exponent before doing the operations that are inside the parentheses. As far as the subtraction and multiplication goes, it's going to happen pretty much the same way. Again, you're going to want to remember the normal things that you should consider, like using the parentheses for the subtraction and for the multiplication. But that big cube root over the 6 minus 3x is going to limit a lot of what we can simplify and what we're able to collect together. So you'll notice here the expressions for f minus g and for fg of x. With how complicated the multiplication of the two functions is with the expression, either form would be acceptable to write. Is really just a matter of taste. Now that you have an idea of some of the different things that you might run into when adding, subtracting, multiplying, or dividing functions, now you need to go practice some more of these on your own so that you can see if there's any more unexpected things for you that come up, and so that we can talk about those and really get our heads around this important understanding of functions.